All right, hi guys, and welcome to Section 6 review. So let's jump right in. Number 1, name each polynomial by degree and by the number of terms that there are, and also state the end behavior. Okay, so let's start with part A. Everything is already simplified, so let's go ahead and take a look at our leading term. Our leading term is going to tell us the degree, and it's also going to tell us the end behavior. So the leading term is the term with the highest power, which would be this first term. Now, the degree is the power of that leading term, which is the highest power, so the degree is 4. Now, the degree of 4, we call that type of polynomial, we call it quartic. We also need to classify by the number of terms. So we have here 1, 2, 3, 4 terms. So on this one, 4 terms, we would just call it a polynomial of 4 terms. Then for the end behavior, we can go back to that leading term. So the power is an even number, so that is even, and the coefficient in front is a negative. So this one is even and negative. Remember, even, both ends face the same direction, and because it's negative, both ends are facing down. So as x approaches positive infinity, on the right-hand side, the function approaches negative infinity, goes down, and on the left-hand side, as x approaches negative infinity, the y value goes down as well to negative infinity. Okay. All right, so let's move on to part B. So on part B, we need to distribute the negative x, because this is not simplified. Negative x times 9x squared would be negative 9x cubed. Negative x times positive x is negative x squared. And then negative x times negative 12. Negative 1 times negative 12 is positive 12. X times x squared is x cubed. So now we can actually simplify further. Negative x squared we cannot simplify with anything, so I'll just write that down. But negative 9x cubed plus 12x cubed actually gives us 3x cubed. So now that we have it completely simplified, let's go ahead and focus on our leading term, which is the term with the highest power. In this case would be this one right here. So the power is 3. That tells us the degree. A polynomial with degree of 3 means it is cubic. And then we can go ahead and classify by the number of terms. The number of terms, there are 2, which is called a binomial. And then for our end behavior, based on the degree, we already know the power, right, is odd. And then the leading coefficient is positive. So this is odd and positive, which means that we are facing opposite directions, overall going up from left to right. So as x approaches positive infinity on the right-hand side, that y value is going up to positive infinity. And then as x approaches negative infinity on the left-hand side, the y value is actually going down to negative infinity. All right, let's move on to the last one, part C. So part C is also not simplified, so I'm going to go ahead and distribute the negative 4x, bring down the x cubed. Negative 4x times x squared is negative 4x cubed. Negative 4x times 1 is negative 4x. And then we can bring down the positive 3x cubed. Now, 1x cubed minus 4x cubed is negative 3x cubed. Plus 3x cubed will actually cancel. So all of this cancels, and you actually only end up with negative 4x. So the degree there's only one term, so that's your leading term. The degree is 1, which means that it is linear. And by number of terms, there's only one term, which means that it is monomial. One-term polynomial. And then for our end behavior, the degree is odd, but the coefficient is actually negative on this one. So it is facing opposite sides, but overall going down from left to right. So as x approaches positive infinity on the right-hand side, that y value is going down to negative infinity. And as x approaches negative infinity on the left-hand side, that y value is actually going up to positive infinity. All right. And let's move on to number 3. So number 3, select all of the operations in which integers are closed. Integers are just positive or negative whole numbers. So if I take an integer and I apply any one of these operations within another integer, the question is, do I always get an integer? Okay. So the first one is multiplication. If you take an integer and you multiply an integer, do you always get an integer? Yes. So multiplication works. If you take an integer and you divide it by an integer, do you always get an integer? No. For example, integer 1 divided by integer 2, you get a result 1/2. 1/2 is not an integer. So no. For subtraction, if I take an integer and I subtract another integer, do I always get an integer? Yes. And then lastly, for adding, if you take an integer and you add another integer, do you always get an integer? Yes. All right, so let's move on to number 3. Number 3 says use polynomial identities to factor. Okay, now I do see here that this is a perfect cube and 81 is a perfect square. Now 343 is actually a perfect cube and y squared is a perfect square. So let's go ahead and distribute the negative here. So we get x cubed minus 81 minus 343 plus y squared. And we could check that 343 is a perfect cube by taking the cube root. So index 3, second, any root, 343 is 7. So if I switch around these terms and I put the 343, which is a perfect cube with a perfect cube, and I take the y squared and I bring over the negative 81 next to the other perfect square, now we can see that these two grouped together will be the difference of cubes, and then these two grouped together will give me the difference of squares. So x cubed will be x all cubed. 343 we just saw is 7 cubed. Y squared would just be y, that is squared. And 81 would be 9 squared. So now I can use the identities for the difference of cubes and the difference of squares. Remember that the difference of cubes, a cubed minus b cubed, is a minus b times a squared plus ab plus b squared. And the difference of cubes, a squared minus b squared, factors into a plus b times a minus b. So using the difference of squares identity, right, where a is x and b is 7, this would factor into x minus 7 times x squared plus x times 7 plus 7 squared. And then here, this difference of squares where a is y and b is 9 would factor into y plus 9 times y minus 9. Okay, so now let's go ahead and simplify this last trinomial right here. So I have x minus 7 times x squared, which is x squared, x times 7, which is 7x, and 7 squared, which is 49. And then I could just bring these two down. All right, and we cannot factor any more. So that is as much as we could factor. All right, let's move on to number 4. So on number 4, I need to factor the expression. Now I see that I have 4 terms, and in all these 4 terms, I could factor out a 6. So that's what you should always do, is factor out the GCF first. If I factor out 6, remember factoring out is division. So 6x cubed divided by 6 would be x cubed. Negative 12 divided by 6 is negative 2. Negative 18 divided by 6 is negative 3. And 36 divided by 6 is 6. Then I can go ahead and try to group to factor since I have 4 terms. So I could try to group the first 2, factor out as much as I can, plus group the last 2, factor out as much as I can. So if I do that, I could factor out x squared from the first 2 terms. X cubed divided by x squared is x. Negative 2x squared divided by x squared would be negative 2. From these last 2, I could factor out a negative 3. Negative 3x divided by negative 3 is positive x. 6 divided by negative 3 is negative 2. Now when I do that, I do see that I have the same exact binomial. So grouping to factor will work on this one. So same exact binomial, which means that I could factor that out. And that remains me with x squared minus 3. So my final answer is the 6 times the x minus 2 times the x squared minus 3. This is a perfect square, but 3 is not a perfect square, so that is not the difference of squares, and that is as much as I can factor. All right, let's continue on to number 5. Okay, So for number 5, we need to consider the following end behavior. And they're asking us which of these functions has this end behavior. Okay, so you need to look, what does this say? This says the y value goes down as the x value goes up. So the x value goes up, that's the right side, and the y value is going down. So there are two ways that the right side can go down, right? Either the left side is also going down, or the left side is going up. But both of these have the right side going down. So either you can have it be odd or even. If it's odd, it would have to be going down from left to right, negative. And if it's even, you would have to have both sides going down, so negative as well. So when you're looking at all of these, right, we need to simplify first. So 3x to the power of negative 7. This x to the power of negative 7, we could change the side of the fraction that that's on. So this is really x cubed plus 7 minus 1/3 times x to the power of 7. We can bring that x to the power of 7 to the numerator. So what is the leading term? The leading term, now that it's simplified, is the term with the highest exponent, which is 7. And this is odd and negative. That meets our criteria. So that is one of the answers. Moving on to the second one. This one's already simplified. What is the leading term here? X to the power of 4. So this one is even and positive coefficient. So no, that does not match our criteria. No. The next one, we need to simplify, distribute negative x. So we have negative 3x squared plus x minus 3x plus 2x to the power of 5. So this one, the term with the highest power, and here we could do x minus 3x would give us negative 2x, okay? But it would still be negative 3x squared minus 2x plus 2x to the power of 5. So 2x to the power of 5 is still our leading term. And so that means that the power is odd and the leading coefficient is positive. That does not meet one of our criteria with the right side going down, so that is also not an answer. Moving on to the next one, this is already simplified. We have our leading term is the term with the highest power right here. So this one, power is even and coefficient is negative. So that is one of our criteria, right? Both sides are going down, so the right side will go down. That is also an answer. And then the last one, already simplified. This is the term with the highest power. So power is odd, coefficient is positive. So odd and positive will go up overall from left to right. So the right side is not going down, it is going up. So that is also not one of our answers. Okay. Let's move on to number 6. So number 6 says, determine the degree of the polynomial function with the given data. So when we're determining the degree, all we have to do is find the successive difference. So we need to find the difference from 50,544 to 9,919. So if we take 9919 and we subtract 544, we get negative 4625. And then we want to do that down the list, okay? So we want to subtract each time this number minus this number, that'll be the difference there, and then so on and so forth. So let me do that really quick for the first one, and go. Okay, so now we have the first difference. Now the first difference, do you notice that they are not all the same? So that means that this degree is not 1. So now we're going to go ahead and take the differences of the differences. We're going to find the difference from the first difference. So I'm going to go ahead and figure out negative 9375 minus negative 4625. What is that? So it's positive 31,250. And then I'm going to go down the list, and that'll be my second difference. So let me go ahead and do the calculator with all of these. Okay, So we see now the second difference is not all the same. So we got to do this again for the third difference. Let's take the differences of these differences. So again, you always find the difference the same way. How do we get to 31 from 31,250 to 8,750? Well, let's go ahead and figure that out. 8,750 minus 31,250. What do we get there? Negative 22,500. And we're going to go through the list and do those. Okay, so bad news. Those were also not the same differences. So we have to do this one more time, right? Negative 7,500, what is the difference between those two? So negative 7,500 minus negative 22,500. So I would have to subtract 7,500. I think I messed up there. Hold on, let me double check that. Oops, I had one too many negative 7,500s. So let me clear that, do that one more time. Negative 7,500 minus 22,500 minus negative, which is really a plus. So let's just change that to a plus. 22,500, we get 1,500. So I need to add 15,000 to this in order to get to negative 7,500. And it actually follows, if I add 15,000 to negative 7,500, I get 7,500. And if I add 15,000 to 7,500, I get 22,500. So notice the fourth difference is all the same, which means that this is degree 4, which is called quartic. All right, let's move on to number 7. Okay, so on number 7, we have Vito stated that polynomials are closed under division. This is false, right? Because if we take a polynomial and we divide it by a polynomial, we do not get a polynomial. Polynomial divided by a polynomial is not always equal to a polynomial. So that means that it is not closed under division. So what are 3 different counterexamples for the statement? Any polynomial that has a smaller degree that is in the numerator than the degree that is in the denominator will be a counterexample. Because this will show that once you simplify, you end up with more variables in the denominator, and you cannot have variables in the denominator. So there's one counterexample. Here's another counterexample. Let's say x plus 3 over x squared plus 3x plus 7. As long as the degree of the top is smaller than the degree of the bottom, then once you divide, you will still have a variable in the denominator, and therefore it is not a polynomial. They said 3 different ones, so let's do another one. How about x squared plus 3x minus 7? I mean, I don't know, I think I'm just picking 3 and 7 because they're coming to mind. And then over, let's go with 9x to the power of 5. As long as the degree in the denominator is bigger than the degree of the numerator, it's going to show that is not a polynomial, because that's not going to be a polynomial. All right, moving on to number 8. On number 8, it says, which of these polynomials has 2 as a 0? Okay, so what you want to do is you want to do this 2 ways. You could either do synthetic division or you could plug it in, right? We could either do synthetic division by plugging in, by checking is x minus 2 would be the factor, right? If I divide this by x minus 2, is the remainder going to be 0? So you could check it that way. 2 times 1 is 2, add, we get negative 3, multiply negative 6, add, we get 2, multiply, we get positive 4, add, we get 8. So no, it doesn't work for the first one. Then we check the next one, and again, you could either check with synthetic or you could plug it in. So if we check g of 2, right, if I plug it in, 2 cubed minus 5 times 2 squared plus 7 times 2 minus 1, and I simplify all of that, that's not going to be 0. Okay, so it doesn't work on this one either. And you can go through and check them either way. I personally think using synthetic is easier, so that's what I'm going to do for the remaining of these. So let's check on this one. Coefficients are 1, -6, 11, and -6. Bring down the first term. 1 times 2 is 2. Add, we get -4. Multiply -8. Add, we get 3. Multiply 6. Add, we get 0. So that one works. H of x does have 2 as a 0, which means that x minus 2 is a factor. Okay, didn't ask for that, but just, side note. All right, let's check J of x, coefficients. And remember, if there's any missing terms, you want to have a 0 for a placeholder. We don't have any missing terms here, so coefficients are 4, -1, -13, -14, and 24. All right, bring down the first one. 2 times 4 is 8. Add vertically 7, multiply 14. Add vertically 1, multiply 2. Add vertically -12, multiply -24. Add vertically 0. Works for that one as well. Awesome. So J of x also has 2 as a 0. And then last one, let's go ahead and check. Coefficients are 8, -1, -15, 21, and -4. Bring down the first one. 2 times 8 is 16. Add vertically, we get 15. Multiply 30. Add vertically, we get 15. Multiply 30. Add vertically, we get 51. Multiply, that's 102. Add vertically, we do not get 0. We get, actually, that would be like 90. Whatever, it doesn't matter what it is. The remainder, the problem is that it's not equal to 0. So no. So that it's not going to work for this one either. So the answers are H of x and J of x. All right. Moving right along to number 9. Consider the function, sketch the graph of f of x. Okay, for the sketch, we need the end behavior, and we need the zeros and their multiplicity. Now the nice thing is the zeros, we set f of x to equal 0, and all of these are already factored. So we could just set each factor equal to 0. So 0 equals -x plus 5, 0 equals x minus 2, and 0 equals x plus 3. So we have 3 zeros. -5 divided -1, we get 5. And that is a 0 3 times. That has a multiplicity of 3. Then another 0, we have x equals 2. And that was a factor twice, which means that this 0 is a 0 twice, has multiplicity 2. And the last one, -3, that is only a factor once, so that just has a multiplicity of 1. Remember, your multiplicity tells you how many ways you're going to pass through the 0. If the multiplicity is 1, you just pass through the 0 straight. If the multiplicity is greater than 1, and that is an even multiplicity, then you're going to hit the 0 and bounce back. It's going to look tangent to the x-axis. And if your multiplicity is greater than 1 and it is odd, then what you want to do is you want to go through the 0, but you want to flatten at the 0. So you want it to be horizontal at the 0. Okay, so what about the end behavior? Remember, from factored form, what we need for end behavior is the leading term. Instead of having to multiply all this stuff out so that we could see the leading term, there's a trick to find the leading term. You take your coefficient in front and then every variable with its power and multiply them all together. So that the leading term would be 3 times -x cubed times x squared times x to the power of 1. Now, -1, excuse me, cubed is -1. -1 times 3 would be -3. And then x cubed times x squared times x to the power 1 is x to the power 6. So this is -3 x to the power 6. So the power tells us it is even, and the coefficient tells us it is negative. Even and negative has end behavior where both ends are facing down. Excuse me, I was drawing those up. Even and negative. So both ends are even, facing the same direction. Negative means they're both facing down. Now we can go ahead and graph. Let's graph all of our zeros, -3, 2, and 5. Then we want to graph our end behavior. On this side is going down. This side is also going down. So starting on the left-hand side, we're going to go through this 0 straight, because the 0 of -3 has a multiplicity of 1. I got a little jagged there, so let's try to fix that. But you're going to go through it straight, okay? Then you're going to turn back around so that you can go through the 0 of 2, and that has a multiplicity of 2, so it has an even multiplicity, so we're going to hit the 0 and bounce back. And then lastly, when we go through 5, we're going to go through 5, but we need to flatten at the 0. So just so I can flatten, I'm going to erase the end behavior here and just move it over so that it looks flat at the 0. And that is the graph for number 9. Let's move on to the graph for number 10. Now, number 10, we need to sketch this graph. We have another function. We still need the end behavior. We still need the zeros. Now, the nice thing is that because this is not factored, you have the leading term right away, which is the term with the highest power. And the power tells you that it is even. The coefficient tells you that it is positive. So even and positive, both ends are facing up. Even means both ends are facing the same direction. Positive means they're both going up. Now for this one, if you look, it's not factored, right? So that's the bad part, is that we are going to have to find the zeros. Now, in order to do that, I need a factor. So I'm going to go ahead and I'm going to factor out an x from all of the terms. So that's going to give me 3x cubed plus 7x squared plus 5x plus 1. Now, I cannot group to factor on this one, so I have to do the p over q thing, okay? Remember, p's are all of the factors of your constant term. The factors of 1 is just 1. Q's are all of the factors of the leading coefficient. The factors of 3 would be 1 and 3. And then p over q is taking each p dividing by each q. So 1 divided by 1 is 1. 1 divided by 3 is 1/3. So the possible zeros here are 1, negative 1, 1/3, negative 1/3. So we need to go ahead and check these, okay? Let's start with checking 1. So 3, 7, 5, 1. We bring down the first term. Oops, that's a 3. 1 times 3 is 3. Add vertically 10. 1 times 10 is 10. Add vertically 15. 1 times 15 is 15. Add vertically, that does not give a 0. So 1 is not a 0. We can go ahead and use the same table. Let's go ahead and erase these numbers, and now we're going to check the next 0, which is negative 1. Bring down the first one, multiply negative 3, add vertically we get 4, multiply we get negative 4, add vertically we get 1, multiply we get negative 1, add vertically we get 0. Awesome, we found one. So now that we found one, let's go ahead and factor it out. So if negative 1 is a 0, right? So I'm factoring this one. If negative 1 is a 0, that means that x plus 1 is a factor. So if I take this polynomial right here and I divide it by x plus 1, I'm going to get the result of 3x squared plus 4x plus 1. And then this is just a trinomial, so I can factor, right? Rainbow over, since the a value is not 1, multiplies to 3, adds to 4, easy. 1 times 3, 1 plus 3. So this is going to factor. If we split 4x into 1x plus 3x, and we group the first two, right, then we could factor out an x from the first two, which gives us 3x plus 1. And then from 3x plus 1 on the last two, we could factor out a positive 1 as a placeholder, which gives us 3x plus 1. And then we could factor out 3x plus 1. So the final factored version will be x times x plus 1 times, if we factor out 3x plus 1, we get x plus 1. So we actually have x plus 1 twice. So we could rewrite this. I'm going to skip over this end behavior here, or excuse me, this synthetic division table. So we actually have 2 copies of x plus 1, so we could write this as x times x plus 1 to the power of 2, 2 copies of that, times x plus 3x plus 1. So we have 3 zeros. 0 with a multiplicity of 1, negative 1 with a multiplicity of 2, and negative 1/3 with a multiplicity of 1. Because this has a power of 1, 1 copy. This has a power of 1, 1 copy. This has a power of 2, 2 copies. So now let's go ahead and graph our 3 zeros. 0, negative 1, and negative 1/3. Well, this is terrible graph. Negative 1, 0, and negative 1/3. There we go. All right, this is going to be tough because it's like very, very small. All right, so we're going to stop start on the left-hand side above. We're going to hit the 0 of -1 that has a multiplicity of 2. So I hit the 0 and I bounce back. Then I need to turn around to go through 1/3 straight, and I need to turn around to go through 0 straight, and then all the way up on the right-hand side as well. So here, this is tangent, right? I hit the 0 and bounced back because the multiplicity was 2. Here went through it straight, and here went through it straight. It's just this a very small graph because, you know, of the x-axis being all of the zeros are close together. But that's the general shape. That's what it should look like. All right, let's move on to number 11. So on number 11, we need to consider the function f of x. And what we need to do is find the y-intercept of the function and then factor the function and state all the zeros. Okay, well, the y-intercept is easy. Remember, the y-intercept of any polynomial is just a constant term. So the y-intercept is just -4. The next question says factor and state all the zeros. So let's go ahead and factor. Now this one I can actually group to factor. There are 4 terms, group the first 2 plus group the last 2. If we factor out x squared from the first 2 terms, we're going to get x plus 1. If we factor out -4 from the last 2 terms, we're going to get x plus 1. So then I can factor out that same binomial of x plus 1, and that'll give me x squared minus 4. Now we are not done here because x squared minus 4 is the difference of squares. X is x squared, 4 is 2 squared, so this is the difference of squares. The difference of squares, the identity a squared minus, b squared factors into a plus b times a minus b. So x squared minus 2 squared factors into x plus 2 times x minus 2. And I cannot factor any further, so this is my factored form. From there, I can go ahead and find the zeros by setting the f of x function to equal 0. Remember, finding the zeros is just finding the the x-intercepts. So all of these things are multiplying together. They have to equal 0, which means that either one of the factors could equal 0, and that would give me a solution. So if I set each factor to equal 0, I get the solutions -1, -2, and +2. All right, moving right along, number 12. So a polynomial function is shown here. Classify the polynomial by degree, number of terms, and also state the end behavior. All right, remember, in order to classify, you need to simplify first. So let's take f of x, and we need to simplify -x here. So x squared I'm just going to bring down, but -x times 3x squared is -3x squared. Negative times -2 is +2. Ooh! Wait a minute. Wait a minute. I did not notice. Do you see? This has a power. Uh-oh, I cannot multiply before I do exponents. So let me hold the phone here. I didn't notice that exponent there until just now. So I'm going to leave that minus on the outside. I need to do 2 copies of this multiply together first. So 3x squared minus 2 times 3x squared minus 2. I need to deal with that. So 3x squared times 3x squared is 9x to the power of 4. 3x squared times -2 is -6x squared. -2 times 3x squared is -6x squared. -2 times -2 is +4. Then I can actually group the middle 2 terms and distribute the negative. So if I group the first 2 terms, the middle 2 terms, it will be -12x squared. And then if I distribute the negative, it's going to change the sign of each term. So I have x squared minus 9x to the power of 4 plus 12x squared minus 4 plus 5. The 1x squared I could add with the 12x squareds, which give me 13x squared. -9x to the power of 4 I can't combine with anything, and -4 plus 5 is +1. Now, how do we determine the degree? Well, you look at the term with the highest power. That is also your leading term, which is what you use for the end behavior. So your degree is 4, which means this is quartic. We have 3 terms, which means it's a trinomial. And end behavior, it is even, power, negative coefficient, so both ends are going down to negative infinity. So on the right-hand side, as x approaches positive infinity, the function f of x is going down to negative infinity. And on the left-hand side, as x approaches negative infinity, the function f of x is also going down to negative infinity. Okay, number 13, find all the zeros. Okay, so we have three terms, right? Let's try to see if we can factor in the regular way. The a value is 1, the coefficient is 1. So multiplies to negative 8, adds to negative 2. Let's see. Yeah, 4 and 2, right? Negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. So this actually factors. And this is easy factoring because of the coefficient is 1, right? But be careful because the variable in the middle is not just x, it's x squared. So this is x squared plus the one number times x squared plus the other number. If you wanted to split the middle and do all of that, you can, but that's how it would factor. Then you have here the difference of squares, right? This is the same exact thing that we had up here. X squared minus 4 is x squared minus 2 squared. And so this factors into x plus 2 times x minus 2. The x squared plus 2 is not the difference or sum of squares, so that's just going to stay like that. So this is it completely factored. Now to find the zeros, we set the f of x function equals 0, and then we're going to solve for each of the zeros, right? So each factor is set equal to 0. Here we get x equals negative 2. Here we get x equals positive 2. And then here, x squared plus 2 equal to 0. Subtract 2 on both sides, we get x squared equals negative 2. And then square root both sides, we get x equals plus minus the square root of negative 1, which is I, and then the square root of 2, which is just square root of 2. So here are 2 zeros, 3 zeros, 4th 0, 4 total zeros. We got all of them. All right, let's move on to number 14. So 14 says, for which of the following is x minus 5 a factor? Well, if x minus 5 is a factor, that would mean that 5 is a 0. So really, if you're checking if x minus 5 is a factor, you're checking is 5 a 0. So again, you can check this the same way that we checked the other problem on number 8, right? You could either check it by synthetic or you could check it by plugging it in. So let's go through, and I'm going to use synthetic. So here we do have a missing term. We have a missing constant term, so I have to put a 0 for a placeholder there. I'm going to check if 5 is a 0. Coefficients are 1, negative 4, negative 5, and that 0 for a placeholder for the constant term. Bring down, 5 times 1 is 5. Add vertically, we get 1. Multiply 5. Add vertically, we get 0. Multiply 0. Add vertically, we get 0. So that works. Awesome. So this one is good. Let's move on and check g of x. So here, no missing terms, so coefficients are 3, negative 5, negative 47, and negative 15. Bring down the first one. 3 times 5 is 15. Add vertically, we get 10. Then multiply, we get 50. Add vertically, we get 3. Multiply, we get 15. Add vertically, we get 0. So awesome, another one that works. Okay, great. Let's now check the next one, h of x. So coefficients there are no terms missing. We have 3, 4, negative 21, and 13. 3 times 5 is 15. Add vertically 19. Multiply 5 times 19. Let's see. 5 times 19 is 95. Add vertically 95 plus negative 21 is 74. And then 74 times 5 is 370. Let me just verify that. Yep. And then add vertically, we get something that's not 0. Okay, it's 383, but it's not 0, so that one doesn't work. Okay, checking m of x of coefficients, 3, negative 5, negative 3, and 5. So 3 times 5 is still 15. Add vertically, we still get 10. Multiply, we get 50. Add vertically, now we have 47. 5 times 47 is 235. And then when we add that with 5, we get not 0. Okay, so that's what matters. So no good. Last one, 5. Coefficients 1, -4, -2, and -15. So 1 times 5 is 5, add vertically 1, multiply 5, add vertically 3, multiply 15, add vertically 0. Awesome, so the last one worked. Okay, so those are the ones, f of x, g of x, and p of x. Okay, consider the graph of the following, which is the model. Oh, so this is a multiple choice. Okay, cool. So first thing I notice that the left side is up and the right side is down. That means that this is odd. Not only is it odd, but it is overall down from left to right, so it is odd and negative. Based on that, I can try to cancel out some of these. So what is the leading term for all of these? For the first one, it's -1 times x to the power of 1 times x to the power of 2. So -1 times x to the power 1 times x to the power 2 would give us a leading term of -1 x to the power 3. So odd and negative, that one's good so far. On the next one, -1/3 x to the power of 1 times x to the power of 1 times x to the power of 2. So this is actually going to be -1/3 x to the power of 4. So this is even and negative, so that one's out of the running. Moving on to the next one, we have -1/3 times, oh, this is the same thing, -1/3 times x to the power 1 times x to the power, oh no, times x to the power of 1 times x to the power of 1. So we actually do have a negative and odd. So this one is still in the running as well. This is also odd and negative, just like this one is odd and negative. Last one, -3 times x to the power of 1 times x to the power of 1 will be x to the power of 2, right? So this will be negative and even. So that one is out of the running. So now we're down to A or C. So which one is it? Is it A or is it C? Well, let's look at the zeros. This polynomial has a 0 of 0, a 0 of 2, and a 0 of -1, right? Those are all 3 zeros. All of them have a multiplicity of 1. This one, on the other hand, has a 0 of 2 and a 0 of -1. The 0 of 2 has a multiplicity of 1, and the 0 of -1 has a multiplicity of 2. So that's the 3 of them. It's just that -1 has a multiplicity of 2. So let's check. Is 0 a 0? No, because the graph doesn't go through there. So -1 has even multiplicity. Notice it hits the 0, bounces back, right? And the 0 of 2 has a multiplicity of 1. Notice it goes through it straight. So the correct answer is A, because that's the one that has -1 with a multiplicity of 2, that even multiplicity, and with 2 with a multiplicity of 1. 0 is not a 0, so that one is wrong. Okay, move right along to number 16. So on number 16, we're asking for the end behavior of this function. Now again, for the end behavior, all you need is the leading term. In order to find the leading term, when it is in factored form like this, all you have to do is take your coefficient and your variable with its power and multiply them all together. So we have -x times x cubed times x to the power of 1 times x to the power of 1. That'll give us negative x to the power 1 times x to the power 3 is x to the power 4 times 2 more copies is x to the power 6. So this is even and negative. Even and negative, both ends are going down. So as x approaches positive infinity on the right-hand side, the function f of x goes down to -infinity, and as x approaches negative infinity on the left-hand side, f of x approaches negative infinity as well. Okay, number 17, expand. All right, now we need to use Pascal's triangle for this, right? Remember that the power, 1 more than the power is how many terms you're going to have. So this is, if this is binomial to the 5th power, that means we're going to have 6 terms. So remember, for Pascal's triangle, you start with the triangle of 1s. You start with a 1, add what's on top, end with a 1. Start with a 1 for your next row, add what's on top, end with a 1. Start with a 1, add on top, 3 plus 1 is 4, end with a 1. So now we have 5 terms, right? We need 6 terms. There's always one higher than the power. So one last row, 1, add on top, add on top, add on top, add, end with a 1. So our coefficients is going to be 1 plus 5 times something plus 10 times something plus 10 times something plus 5 times something plus 1 times something. Now remember, your first term, you're going to take that's going to have the highest power 5, then power 4, then power 3, then 2, then 1, all the way down to 0. Okay, so that's the first term. So it's y squared to the power 5, y squared to the power 4, y squared to the power 3, y squared to the power 2, y squared to the power 1, and then y squared to the power 0. Your second term, okay, you're going to start with the highest, but on the right-hand side. So that second term to the power of 5, then moving to the left to the power of 4, then to the power of 3, then to the power of 2, then to the power of 1, and then finally to the power of 0. So that second term is negative 2x. So negative 2x to the power 0, negative 2x to the power 1, negative 2x to the power 2, negative 2x to the power 3, negative 2x to the power 4, and negative 2x to the power 5. Now, we need to simplify each of these. Okay, I like to simplify by term. So we take the first term, that's just 1. Y squared to the power of 5 will be y to the power 10. Moving on to the next one, we actually have negative x to the power of 1. So that'll be negative 2x. Negative 2x to the power 1 is just one copy, so that's negative 2x. Negative 2 times 5 is negative 10. Y squared to the power 4 is y to the power of 8. So this will be x to the power of 1, y to the power of 8. Moving right along, negative 2 squared. That negative 2 squared is actually 4. X squared is just x squared, right? And then y to the power 2 to the power 3, which would be y to the power 6. But that 4, I can multiply with 10, is 40. And then x squared y to the power 6. Remember, when you have multiple variables in the same term, you write them in alphabetical order. Lastly, negative 2 cubed is negative 8. X cubed is, of course, x cubed. Y squared squared is y to the power 4. Negative 8 times 10 is negative 80. And x cubed, y to the power 4. Okay, next one, we have negative 2 to the power of 4, which would be negative 2 times negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4. Negative 2 times negative 2 is 4. 4 times 4 is 16. Positive 16. At positive 16, and then x to the power 4 is x to the power 4. Y to the power 2 to the power 1 would just be y to the power 2. 16 times 5 is, I'm going to be lazy a little bit, 16 times 5 is 80. So that's positive 80. X to the power of 4, y to the power of 2. And then the last one is negative 2 to the power of 5, which is negative 32, x to the power of 5, and then anything to the power of 0 is just 1. So that last term will just be 1 times negative 32x to the power of 5, which would be the negative 32x to the power of 5. And that is the expansion. Okay, number 18. Ooh, okay, fancy. Find the roots of f of a. Here's f of a. All right, what are the roots? Wow, remember roots are the same thing as zeros, right? So really we're looking for the zeros here. Now, I could find the zeros by setting f of a to be 0, setting the output to be 0. And then I need to factor this in order so that I could set each factor to equal 0, right? I could use a zero product property. I could factor out a. And once I do that, I get 4a squared minus 49. Do you notice that both of these are perfect squares? So I could use the difference of squares. Remember, a squared minus b squared factors into a plus b times a minus b. So what are the a and b values? Well, a is whatever the first term is as a square. And b is whatever the second term is as a square. So the second term will be 7 squared, so that's your b value is 7. And the first term will be 2a squared, so that's your a value is 2a. So this will factor into 2a plus 7 times 2a minus 7. And now each of those factors set to equal 0. A equals 0 would just give you a equals 0. 2a plus 7 equals 0. You would subtract 7 and then divide 2. So a equals negative 7 over 2. And the last one, 2a minus 7 equals 0, you would add 7, positive 7, and then divide 2. So you get a equals positive 7 over 2. So we have 3 zeros for our degree 3. Okay, 19, another question, find the zeros. Now, we have 4 terms here. I think I can group to factor. Let's go ahead and try it. Group the first 2, group the last 2. From the first 2, we could factor out x squared, which gives us x plus 7. And then on the last 2, we could factor out -1, which gives us x plus 7. So yes, great, I have x plus 7 on both, which means that I could factor out, it's a parentheses. I don't like that. Let's go ahead and fix that. All right, which means I can factor out x plus 7 on both. On the first term, that would just leave me x squared. On the second term, that would leave me with -1. Now, you might think you're done, but you are not, because this is the difference of squares, right? Difference of squares. A squared minus b squared factors the a plus b times a minus b. The a value would be x, the b value would be 1. So this final factored form will be x plus 7 times x plus 1 times x minus 1. So what are the zeros? X plus 7 equal to 0 gives you the 0, -7. X plus 1 equals 0 gives you the 0, -1. And x minus 1 equals 0 gives you the 0, x equals 1. Okay? So those are your 3 zeros. Let's verify. Let's make sure we had power 3. Yes, we got all of them. All right. Moving on to number 20. So on number 20, they're asking us to factor. Okay, that's easy. Both of these, do you notice that they are both perfect cubes? They're not both perfect squares, but they are perfect cubes. So I need to write it as something cubed minus something cubed. Remember the identity. A cubed minus b cubed will factor into a minus b times a squared plus a times b plus b squared. That is the identity. So what's your a value? It's x squared, because x squared cubed is x to the power 6. What's your b value? It's 2, because 2 cubed is 8. So your a value is x squared, your b value is 2. Let's go ahead and use the identity. A minus b times a squared plus a times b plus b squared. Now all we have to do is simplify this trinomial. X squared squared is x to the power of 4. X squared times 2 is 2x squared. 2 squared is 4. And that's all she wrote. Number 21, factor again. All right, we can factor out a GCF on this one. We can factor out 5. And then we get x cubed minus 8 y cubed. So we have the difference of cubes again. In this case, a is just x and b is 2y. So difference of cubes, we'll just use the identity. A minus b times a squared plus a times b plus b squared. And then all we have to do is simplify this trinomial. So I'll bring down the first 2 factors. And then x squared is just x squared. X times 2y is 2xy. And 2y squared, 2 squared is 4. Y squared is y squared. All right. More factoring on 22 and 23. Let's do 22. Now this one's actually, I think, going to be a perfect square trinomial. Let's check it. Okay, so first term will be x squared squared. Last term would be 60 squared, because 60 times 60 is 3,600. Now the middle has to check. Remember, a squared plus 2ab plus b squared is the perfect square trinomial. So I need to have 2 times a times b give me this middle value. So is 2 times x squared times 60 169. No. What do I do now? Well, coefficient is 1. 3,600, we're multiplying to 3,600. So what multiplies to 3,600 and adds to 169? Now you could go through the list, I already know the two. It's 25 times 144 is 3,600. 25 plus 144 is 169. So this will factor. We have to multiply to x to the power of 4. So our two here are x squared. That way x squared times x squared is x to the power of 4. But the coefficient is 1, so we could just easily put plus 25 here and then plus 144 here. Now, you're not done. Why are you not done? Because both of these are perfect squares. So we can use the sum of squares, right? What is the identity for the sum of squares? The sum of squares is very similar to the difference of squares. A squared plus b squared factors into a plus bi times a minus bi. So let's first do on these two, and then we'll move on to these two, okay? What are the a and b values here? A is x, b is 5. So a plus bi times a minus bi. Let's move on to these two. What would the a value be? X. What would the b value be? 12, right? 12 times 12 is 144. So a is x, b is 12. So x plus 12i times x minus 12i. And that is the completely factored version. All right, 23. Factor this one. Okay, well, I have a GCF. I can factor out 2, which is y squared minus 8y plus 32 divided by 2 is 16. Now, on this one, I don't know if you noticed, but the first term is a perfect square and the last term is a perfect square. So let's check. Maybe this one will work out. So what's the a value? The a value would be y. The b value would be 4. And then the middle, and remember, if it's minus 2ab, you just have a minus b instead of a plus b. So in the middle is minus 2 times y times 4. Is that equal to negative 8y? Yes, it is. So this is a perfect square trinomial, and so this will factor into a minus b all squared. Okie dokie. 24. Find all the zeros. Okay, there are 5 terms on this one, so I am going to have to use P over Q. Okay? Now, what are the values of P? The values of P are the factors of the constant term. Now, if you went ahead and tried to do all the factors of 32, which is fine, you can do that. However, if you are a little bit more aware of what you got going on and you see that you could actually factor out 4, then that'll make your life a little bit easier. So if we factor out 4, we just have 1x to the power of 4 minus 3x to the power of 3 minus 2x to the power of 2 plus 12x minus 8. And so now, if I factor this one, the numbers are easier to deal with. So this is the one that I'm going to try to factor right here. So P's are all of the factors of 8, which would be 1, 2, 4, and 8. And then Q's are the factors of 1. Well, that's just 1. So when we do P divided by Q, we're just taking 1, 2, 4, and 8 and dividing it by 1, which will give us 1, 2, 4, and 8. Okay? Now, we're going to use synthetic division. We're going to test out some options. Let's go ahead and test out 1. Okay? Now, the coefficients will be 1, negative 3, negative 2, 12, and negative 8. Okay? You bring down your first one. 1 times 1 is 1. Add negative 2. Multiply negative 2. Add, we get negative 4. Multiply negative 4. Add, we get 8. Multiply 8. Add, we get 0. So yes, 1 is a factor. So that means that I could take that and divide it by x minus 1. So right now I have my factor in front, 4. I took this polynomial right here. I divided it by x minus 1, and I got the result right here. 1x cubed minus 2x squared minus 4x plus 8. Then from here, you could try to group to factor. Maybe it'll group to factor. Let's see. Okay, factoring out from the first two, we could factor out x squared. We get x minus 1. X minus 2. And then factoring out from the last two, we could factor out negative 4. We get x minus 2. So yes, group to factoring work. We get x minus 2 on both. So that means we could factor out the x minus 2, and we get x squared minus 4. That remains. Okay, I'm going to bring down these two in front, x minus 1 and 4, those just bringing down. Now, x squared minus 4 is x squared minus 2 squared. So that's the difference of squares. So this one will factor further into x plus 2 times x minus 2. So what do we have? We have a polynomial that has two copies of x minus 2. Now that copy of those two copies of x minus 2, if I set them equal to 0, will give me the solution x equals 2. So the solution x equals 2 has a multiplicity of 2. Then x plus 1 is only a factor once, so the solution of x equals negative 2 will be a multiplicity of 1. And then x minus 1 equal to 0 will give me the solution x equals 1, which again is only a factor 1, so that's multiplicity of 1. Now you don't have to write the multiplicity 1. It is assumed that it's 1. You only have to write the multiplicity when it is more than 1. Okay? And 4 doesn't have a variable, so that's not going to give me a 0. Okay? So we had 4 zeros, right? 1, 2, and then 3, 4, because 0 is a 0 twice. And we got all 4 of them. All right? Number 25. Okay. Again, always factor out a GCF at the beginning first. Here, I could factor out, because I'm finding the zeros again, I could factor out 3x. That gives me 1x cubed minus 7x squared plus 9x plus 17. Okay? From there, I can't group to factor this one. Even though there's 4 terms, the coefficient here is 1, negative 7. Then I have 9 and 17. I can't even factor anything out here, right? So those are not going to match. So I need to do the P over Q thing. P's are the factors of 17. We have 1 and 17. Q's are the factors of 1. We just have 1. So P over Q is just 1 and 17. So let's go ahead and try. 1. We're dividing again this one right here, right? This is what we're trying to factor right here. So the coefficients are 1, negative 7, 9, 17. Bring down 1. 1 times 1 is 1. Add vertically, we get negative 6. Multiply, we get negative 6. Add vertically, we get 3. Multiply 3. Add, not 0. So that doesn't work. Let's erase it and try the next one. What about negative 1? Okay, bring down the first one. Multiply negative 1. Add vertically negative 8. Multiply negative 8. Positive 8. Well, negative 1 times negative 8 is positive 8. Add vertically, we get 17. Multiply negative 17. Add vertically, we get 0. Awesome. So negative 1 is a 0. Okay, so I'm going to bring this down. I already have the 3x factor in front. I took this polynomial. I divided it by x plus 1. And the result that I got is right here. 1x to the power of 2 minus 8x plus 17. Now, this is a trinomial. So I could try to factor it, okay? Multiplies to 17, adds to negative 8. The only things that multiply to 17 are 1 and 17. So we cannot factor this further. So this is the entire factored form. The question is not to factor. If it was, I would be done. The question is to find the zeros. So now I have to set each factor that has a variable equal to 0. Now, if I set 3x equal to 0, that's going to give me a solution. If I divide 3 on both sides, I get x equals 0. So that is a 0. It has a power of 1, so it is a 0 only once. Okay, remember, you don't have to write multiplicity of 1 if the multiplicity is just 1. You only have to write the multiplicity if it's more than 1. So that's a 0. Then x plus 1 equal to 0. Subtract 1 on both sides. We get x equals negative 1. And then what about this one? All of that, x squared minus 8x plus 17 equal to 0, we can't factor. So what do? Well, it's a quadratic, right? So we could use the quadratic formula. X equals negative 8, which is positive 8, plus minus the square root of negative 8 squared, minus 4 times 1 times 17. All going over 2 times 1. So if we simplify by terms, right, we have 8 plus minus negative 8 squared. Negative 8 times negative 8 is positive 64. Minus 4 times 1 times 17 is negative 4 times 17, which is negative 68. And in the denominator, 2 times 1 is 2. Now, what is 64 minus 68? It's negative 4. So we have 8 over 2 plus minus the square root of negative 4 over 2. What is the square root of negative 4? The square root of negative 4 is 2i. The square root of 4 is 2, and the square root of negative 1 is i. So we have 8 divided by 2, which is 4, plus minus 2i divided by 2, which would just be I. So we had 4 zeros. Here's one, here's another one, and then the 4 plus I is the third one, 4 minus I is the fourth one. So that's all 4. All right, 26. So on 26, we need to determine the sign of the leading coefficient, and we need to determine the zeros with their multiplicity. Oh, okay, not that bad. All right, now, both of these ends are facing down. So I know that the power is even. They didn't ask me about that. But the leading coefficient, because they're both facing down, is negative. So the leading coefficient will be negative. Now what about the zeros and their multiplicity? We see the zeros right here. There are the x-intercepts, right? So we have a 0 of 0 with an even multiplicity. Now what that even number is, could be anything. Could be 2, could be 4, could be 6, could be 8, could be 566, whatever. Then the next 0, this is 1, so this is 2. And we're going through it straight, right? So that's a multiplicity of 1. And then lastly, this 0, so this is 3 and this is 4, so that's 3.5. That's also going through it straight, so that's a multiplicity of 1 as well. So those are the zeros with their multiplicity. All right, 27. Determine the zeros and their multiplicity. Okay, so same thing, but now instead of a graph, we have an equation. Now, the zeros are still the same, right? We have negative x to the power of 1. So that'll be multiplicity of 1. Negative x set to equal 0 will give me a 0 of 0. Multiplicity of 1. I'm writing the multiplicity even if it's 1 because now they're asking me to write their multiplicity. Okay. X plus 7 cubed equal to 0. X plus 7 equal to 0 will give me negative 7 as a solution. And that is a 0 3 times, so it has a multiplicity of 3. Then x plus 1 equal to 0 will give me the 0 of negative 1. That has one copy only, so that's multiplicity of 1. And then last one, x minus 1 equal to 0 will give me the 0 of positive 1, and that also is only one copy, so that will have multiplicity of 1. All right. 28, factor the expression. All right, so 28n to the power of 4. Okay, so do you notice how all of these, you could divide them by 4, and all of them you could divide them by n squared. So I'm going to factor out a 4n squared. That'll give me 7n squared plus 4n minus 20. Now, this trinomial, I could try to rainbow over. 7 times negative 20 is negative 140. And we need to multiply that number and add to 4. I'm thinking 14 and 10, right? 14 times negative 10, and then 14 plus negative 10 will add to 4. Yeah, so there we go. We got them. So we're going to go ahead, and now that we have those two, we're going to bring down the front term, bring down the back term, split the middle into those two numbers that I just found, 14n minus 10n. And then now we're going to, now that we have 4 terms, group to factor. So group the first two, we can factor out 7n. That gives us n plus 2. Grouping the last two, we can factor out negative 10. That gives us n plus 2. And now that we have n plus 2 on both, we can factor out the n plus 2, which gives us 7n minus 10. Okay, don't forget to bring down the 4n squared. Everything is factored. No perfect squares or perfect cubes in here. So we are all done. All right. Moving on to number 29. Okay, we're hitting the home stretch, guys. So another expand. Okay, remember you need Pascal's triangle. The power is 4, so we have 5 terms. Start with rows of 1s, or a triangle of 1s, excuse me. Every row you starts with a 1 and ends with a 1. All you do is you add the 2 that are on top, okay? So we're going to start with a 1, and then 1 plus 1 is 2, end with a 1. 1, 2 plus 1 is 3, 3, 1, 1, 4, 6, 4, 1, and those are 5. So that is what we need right there. I'm going to stop right there. I could continue, but what for? We need 5 terms. We have our 5-term coefficients right here. So it'll be 1 plus 4 plus 6 plus 4 plus 1. The first term is x squared. Okay, remember, your left term has the highest power, 4, and then each term that follows goes down 1 power. So power 3, then power 2, then power 1, and then finally power 0. Your second term, well, let me fill that in. I almost forgot to fill it in. It's x squared, right? So x squared to the power 3, x squared to the power 2, x squared to the power 1, x squared to the power 0. Okay. Your second term is positive 3y. Remember that the coefficient in front matters, okay? This case is positive, so that's good. Start on the right-hand side with the highest power, and then power 3, power 2, power 1, power 0. And then we can fill them in 3y to the power 0, 3y to the power 1, 3y to the power 2, 3y to the power 3, and then 3y to the power 4. Now let's simplify. Anything to the power 0 is 1. X squared to the power 4 is x to the power of 8. X squared to the power 3 is x to the power 6. 3 to the power 1 is just 3. 3 times 4 is 12. X to the power 6, y to the power 1. 3 to the power 2 is 9. Y squared is, of course, y squared. X squared is x to the power of 4. 9 times 6 is 54. So this is 54 x to the power of 4 y squared. X to the power 2 to the power 1 is x to the power 2. 3 cubed is 27. Y cubed is just y cubed. Now 27 times 4 is 108. And then x squared y cubed. And then lastly, anything to the power of 0 is 1. 3 to the power of 4 is 81. And y to the power of 4 is y to the power of 4. So this is 81 times 1, which is just 81, y to the power of 4. And that is the expansion. Okay, last page. Here we go. Number 30. Graph the polynomial. Ooh, interesting. Okay. So we can go ahead and factor out 1/2, because factoring out is division, and dividing a number is the same as multiplying a reciprocal. So the reciprocal of 1/2 is 2. So if I factor out 1/2, I will just be multiplying both of these by 2, which is easy to do. So if I factor out 1/2 x squared, right? 1/2 times 2 is 1. And then x to the power of 5 divided by x squared is x to the power of 3. Negative 32 times 2 is negative 64. And then x squared divided by x squared would just be 1. Now, x cubed minus 64, both of these are perfect cubes, okay? So, and the reason why I'm doing this, right, is because I need to find the zeros because I'm graphing. I also need to find the end behavior. I already have that, I just haven't, written it out. But the end behavior I need and the zeros I need. So right now I'm working on the zeros because I'm factoring. Now, x would be x cubed. 64 would be 4 cubed. So this is a cubed minus b cubed. A cubed minus b cubed factors into a minus b times a squared plus a times b plus b squared. So now all I have to do is simplify this trinomial. So I have 1/2 x squared times x minus 4 times x squared plus 4 times x is just 4x, and then 4 times 4 is 16. So 1/2 x squared equal to 0. Multiply 2, we get x squared equals 0. Square both sides, we get 0. But we get 0 twice, guys. This power is 2, right? So this has a multiplicity of 2. And the next one, x minus 4 equal to 0. We get x equals 4, just multiplicity 1. And then x squared plus 4x plus 16 equal to 0. Nothing multiplies to 16 and adds to 4. So I will need to use the quadratic formula. So I have x equals negative b plus minus the square root of b squared minus 4 times a times c all over 2 times a. Now, simplify by terms. 4 squared is 16. Negative 4 times 1 times 16 is negative something. Let's figure it out. 4 times 16 is negative 64. Did I get that right? Yeah, 4 times 16 is negative 64. So we have 16, negative 4 plus minus, square root of 16 minus 64 over 2. Okay, so 16 minus 64 is negative 48, and we can split up negative 48, and both of these are divided by 2. We can split up the square root of negative 48 into the square root of negative 1 times the square root of 16. 16 times 3 is 48 times 3. So negative 1 times 16 times 3 is negative 48, so we can split it up like that. The reason why I want to split it up like that is because the square root of negative 1 is I, the square root of 16 is just 4, and the square root of 3 is square root of 3. So this is negative 4 over 2 plus minus I4 square root of 3 over 2, which would totally be negative 2 plus minus, or in total, 2I square root of 3. So these two are imaginary. So that actually doesn't help me with my graph, but those are them, okay? But for the graphing purposes, we have 5 zeros. 2 of them are imaginary. 1 of them is real right here with a multiplicity of 1, and then 2 other zeros that are multiplicity 2. It's the same 0 twice. So that would be all 5. So we have 0 and 4 are the 2 visible zeros. But 0 has a multiplicity of 2, okay? So it will be hitting and bouncing back on that one. The end behavior is odd and positive. So overall, we're going up from left to right. So we're going to start on the bottom, hit the 0 of 0, bounce back, and then go through the 0 of 4 straight. There we go. Okay, so that's what it would look like. Let's move right along to number 31. So on 31, I'm graphing this one as well. So on this one, we need to go ahead and find the end behavior by doing the trick. Take the coefficient, multiply each variable with its power. Okay, so negative 1 times x to the power 1 times x to the power 2 times x to the power of 3. So that will give me negative 1 x to the power of 6. So this is even and negative. So if this is even and negative, both ends are facing down. And then the zeros, no variable on negative 1. X plus 3 equal to 0, give me the negative 3, multiplicity 1. X plus 2 equals 0, give me negative 2, multiplicity 2. And then x minus 1 equal to 0, give me 1, multiplicity 3. So our 3 zeros are negative 3, negative 2, and 1. Both of these ends are down, so on the left-hand side I start down. When I go through 3, I will go through 3 straight, okay? So we're going through 3. Let me try to fix that. This is like looking weird. We go through negative 3, excuse me, straight. For some reason, my lines are not being very straight right now. All right, there we go. All right. Close enough. Okay. I keep fixing it. All right, we go through negative 3 straight, and we turn back around to go through negative 2. Now, on negative 2, we're actually going to hit the 0 and bounce back because it has a multiplicity of 2. And then we got to turn back around to go through 1, and 1 has a multiplicity of 3. So we're going to go through 3 and flatten at the 0. So we have to flatten at that 0 and then back down for the end behavior. Okay, this side is really bothering me. So I'm going to go ahead and bring this down. There we go. Now we're looking good. All right, so that's what the graph would look like. Last problem, 32. We reached the end. So consider this graph right here. They're saying, what is the value of a? So this function is this right here, okay? You have 1x to the power of 5 minus 13x to the power of 3 plus 4ax. So the question is, what is this a value? So what I need to do is I need to figure out what is this polynomial's equation. That way I can compare it to this equation. So I can figure out the polynomial equation by taking each factor, right? This is a 0 of negative 3, which would have a factor of x plus 3. Then this 0 of negative 2 has a factor of x plus 2. And notice that all of these you're just going through straight. So all of these are just power 1, power 1, power 1. So all of these power 1, power 1. The next one, x minus 0, which would just be x to the power of 1. And then the next one, this 0 of 2 will be x minus 2, and then this 0 of 3 will be x minus 3, okay? So now I need to go ahead and multiply all this out. So let's start with the first two, multiply these two together. X times x is x squared, x times 2 is 2x, 3 times x is 3x, 3 times 2 is 6. If we combine the 2 in the middle, we have x squared plus 5x plus 6. Okay, great. So now I'm going to go ahead and multiply the copy of x in. Okay, I'm not going to multiply the other copies yet. I can only multiply one copy at a time. So now I'm going to go ahead and distribute x, which is easy. X squared times x is x cubed. X times x, 5x is 5x squared. And x times 6 is 6x. Then now I can go ahead and multiply the x minus 2 in. X times x cubed is x to the power of 4. X times 5x squared is 5x cubed. X times 6x is 6x squared. Negative 2 times 3 times x cubed is negative 2x cubed. Negative 2 times 5 is negative 10x squared. Negative 2 times 6x is negative 12x. Okay, before I bring this down, let's go ahead and simplify this one because it is a little bit longer. X to the power of 4 I cannot combine with anything, but I can combine 5x cubed minus 2x cubed is 3x cubed. 6x squared minus 10x squared is negative 4x squared. And negative 12x is negative 12x. All right, last one. Let's go ahead and multiply that last one in, the x minus 3. So if we take x times x to the power of 4 is x to the power of 5. X times 3x to the power of 3 is 3x to the power of 4. X times negative 4x squared is negative 4x cubed. X times negative 12x is negative 12x squared. Negative 3 times x to the power of 4 is negative 3x to the power of 4. Negative 3 times 3x cubed is negative 9x cubed. Negative 3 times negative 4x squared is positive 12x squared. And negative 3 times negative 12x is positive 36x. Okay, now we need to go ahead and combine like terms, right? So if we look, positive 3x to the power of 4 minus 3x to the power of 4 cancels. Minus 12x squared plus 12x squared cancels. Negative 4x cubed minus 9x cubed is negative 13x cubed. Bring down to plus 36x, bring down the x to the power of 5. Now let's compare. Let's compare that with what we have over here. So 1x to the power of 5, perfect. Minus 13x cubed, perfect. And then we need to find the value of a. Okay? The coefficient of the x term is positive 36. The coefficient that they're saying here is positive 4a. Those two have to equal each other. So that means that 4a has to equal 36. If I divide 4 on both sides, that tells me that a is 9. And that is the last question. I hope it was helpful. I'll see you in the next one. Bye.